I think it is. So, hi, my name is Vaibhav. I am a PhD scholar at IIT Madras, and this is Physico-Chemical Processes for Wastewater Treatment. This is the NPTEL course, and this is week 2 online session. And we will study in this lecture these things, water quality parameters. So, in NPTEL lectures, Sir has taught water quality parameters, and I will solve some questions here. We will solve MCQ, fill in the blanks, match the following, and numericals. So, shall we start?
Yeah, sure, sir.
Okay, thank you. So, did you watch the videos which Sir has uploaded?
Yes, sir.
Okay,
I watched some of the videos. I have previous knowledge. Based on that, I have submitted my
okay,
assignment.
okay. So, are you a bachelor or master's or PhD scholar? Can I know?
Uh, I am master's. I have master's degree holder, sir. Organic chemistry.
Nice. Okay, okay, okay. So good. So we will start. I think maybe more people, if want to join, they will join later. So this is
Okay.
the question. Like this is actually as the following. So we will see how to check pH, temperature, and turbidity from which instrument. So like, can you think of the first question? pH can be measured through.
Three ionic testers, sir.
Correct, correct. So I will.
Turbidity through nephrometer.
Hmm. pH ionic tester, temperature through thermometer,
Thermometer.
turbidity
Turbidity through
nephrometer.
nephrometer.
Correct. And temperature affects dash. There are actually uh, four variables which can be affected by temperature. Can you think of those things?
Dissolved oxygen.
Yeah, correct. There are many things also.
Maybe pH also may vary at
Temperature, I think it won't affect. There are some properties more. Okay, I will. In the next slide, you will see. So DO, correct. DO will also vary, and it will change in density. It will
okay,
cause
sir. Density.
density to change, and it will cause viscosity to change.
Yes, sir. Yes. Physical parameters. Okay.
Yeah, density, viscosity. It will cause vapor pressure to change,
Okay.
and surface tension also. So how it is useful, we will see little bit. So DO is useful because if temperature is changed, DO level will decrease. Okay, and if DO level will decrease, it will affect aquatic life.
Aquatic.
Correct, na? And
Yes.
if density and viscosity will change, then it will affect our design. Like we have to design our sedimentation basin, so where the particle will settle. So the Stokes law, which we will study further, that is affected by density and viscosity. And if vapor pressure is affected, it will cause less solubility of gases in the water. And what happens uh, if water is being carried out through hills? So then vapor pressure decreases. If vapor pressure will decrease, then bubbles will form, and if bubbles will form, they will cause some sound, crackling sound, and it will affect the pipes. So in pipe designs, we have to take care of actually vapor pressure, and surface tension is required. I mean, surface tension is affected, then it will affect our processes. Like you need not to worry now. It will affect bubble formation. That is required in actually dissolved air flotation. So when we will study these things, then I will let you know. So this is the same thing. Now this is one more question. Can you think of how it is done? Means how uh, we will match it. Think, tell the units.
Temperature Celsius, sir.
Correct.
Turbidity NTU. Nephrometric turbidity units.
Correct.
Uh, I think order by using ton.
Yeah.
Not,
Reason.
not.
Correct.
I'm
Correct.
not sure about that.
Yeah. Correct. Taste and order is, yeah, correct. Order is
Yes, sir.
threshold order number. This is threshold order number.
Okay, sir. Okay.
Yeah, threshold order number. My writing is not good with this pen tab, but just
No problem, sir.
okay.
No problem.
So order is threshold order number, and taste and order is true color unit.
Okay, sir. Okay, sir.
So let me tell you. Are you aware of TON? Okay, I will tell. So TON is what now? How to measure this order? So
Okay, sir.
order is measured in a 200 ml flask. So what we will do? We will add some amount of water. Like let's say I have taken 50 ml of wastewater. So it has some order. And then I will add 150 ml of distilled 150 ml of water, which is order free, and total
Okay, sir.
will be 200 ml.
200 ml volume.
So what TON formula is? TON formula is A plus B divided by A. So here A plus B will always be, so this will be A sample, this is B,
Okay.
and
Distilled
according,
water.
yeah, according to the formula, if we use it, it will be 200 divided by 50.
Okay, sir.
So it will be 4. So likewise, if this sample has order, then we will further reduce the sample. We will reduce it, let's say 50 ml, and then we will add how much? 160 na?
160. Okay.
160 ml, then it will be 200 now.
200.
Then it
40
will,
by
yeah, 200 divided by 40.
200
So
by
it will be
40.
5. So likewise, we will do, like, let's say if this sample will not produce any order, so this will be our threshold order number. So likewise, we have defined this parameter.
Okay, sir. Okay.
Likewise, true color unit is also like that. We do this by performing some colorimetric test. We make different samples, and that then we check which water sample is corresponding to our wastewater, and then we will say like this is our true color unit corresponding to the standards prepared. Now we will solve one question. This is solids. Uh, do you know what are solids in water or wastewater?
They are maybe organic and inorganic solids. Maybe.
Correct. Anything else? Organics, inorganics. Yeah, these are organics and inorganics. Dissolved and suspended. Are you aware?
Yes, sir. I know about dissolved solids and suspended solids.
Okay, okay.
Dissolved solids we can measure by means of specific conductivity.
Yeah, correct, correct. And
Uh,
suspended, how will you measure?
I don't know, sir.
Correct, I will tell you. See, there are solids. Solids are actually uh, solids have a range that I have taught in previous lecture. So solids are we can define them as uh, any impurity in water uh, which can affect the water quality. So that it's simply I'm defining it. So now we'll talk about the measurement. So solids, like we have defined, some are suspended solids that will be suspended. Some will be
Suspended.
dissolved solids. Okay.
So,
And we have defined further like suspended solids can be inorganic, inorganic suspended solids, and it can be organic suspended solids. Let me give
organic
you an
suspended.
example. Let's say
Clay, okay.
clay or sand. Okay. Organic suspended solids, can you tell me? Just like it can be leaf or any other thing.
Okay, sir.
Likewise, we have defined dissolved solids in two, in two categories. Dissolved solids can be inorganic,
Anorganic.
inorganic dissolved solids, and organic dissolved solids. Organic dissolved solids, let's say organic dissolved solids like sugar,
Okay.
and inorganic dissolved solids. Can you give the example? Inorganic dissolved
Urea.
solids. Yeah, urea is inorganic. Urea is organic.
Oh, okay, sir. Yes, it is.
Any salt you
The
take,
first
that
six.
is any salt you take, that is inorganic
Okay, sir.
dissolved.
Salts, okay.
Correct.
Like sodium chloride, potassium chloride.
Yeah, yeah, yeah. So how many varieties? So one, two, three, four. So we have further few more varieties. We will talk about those solids in the question itself. Okay, like okay, I will tell it here itself. Solids. One, no, 1, 2, 3, 4, 5, 6. There are two more varieties left. Solids. If you take the solids and if you directly heat it at 105 degrees Celsius, you will get total solids. Okay, and
Okay, sir.
from this, if you heat these total solids at 550 degrees Celsius for around 2 to 3 hours, then you will get total organic solids or
Organic
total
solids.
volatile solids. Because what,
Volatile
no,
solids.
sorry, it will be total fixed solids.
No.
Fixed solids. Because what will happen if you heat the total solids at 550 degrees Celsius in muffle furnace, there is a furnace called muffle furnace. So what will happen? All the organic solids will volatilize,
Okay, sir. Okay.
and if they volatilize, only fixed solids will remain here. So total solids minus total fixed solids will give
Fix.
you total volatile solids. I think you got some idea regarding the solids.
Yes, sir. Yes, sir. I
Okay.
understand.
So now we can solve this question. Would you like to try?
A sample collected in industry of a facility of 50 ml. It was used for solid analysis following test analysis using the data to determine the concentration of solids, the drinking water standards. Yes.
Okay, I will start.
Okay, sir.
So we will calculate. See, I will show you. Okay, we'll start in the next slide. Sir. So this is the question. So I'm writing it as, so mass of evaporating dish.
Operating base.
I will write it as W1. So
W1.
we have taken a dish and its weight is this much, 53 grams approximately. So
Okay, sir.
53 grams plus some residue after evaporation at 105 degrees Celsius. I am writing it as
Okay, sir.
W2. Likewise, I am writing it as W3, W4,
W3.
W5, W6. So now we need to calculate. We will calculate all those solids which we studied in the last previous slides. Total solids, volatile
Total
solids.
organic solids.
Yeah, volatile solids are for organic solids
TF.
only. Fixed
Organic
solids,
solids.
and then fixed dissolved solids, fixed suspended solids, volatile dissolved solids, volatile suspended solids,
Hmm.
and suspended solids and dissolved
Right.
solids. So all those things we need to calculate. So if you see well advanced, you will be confused. So solve them one by one. I have a solution, so I will do it. You can check it whether it is wrong or correct. So for total solids, what we will do, we will subtract W2 minus W1.
Minus W1. Okay, sir.
Check what is this. So it will tell you total solids. So the thing is that we need it in the form of concentration. So see here 50 ml of sample. So what we have done, we have taken 50 ml of wastewater, and in that 50 ml of wastewater, we are trying to find all those solids like this. That is the question. Total solids, volatile solids, and all those solids. So for total solids, we need to subtract W2 minus W2 minus W1 That will be in gram divided by 50 ml. How much to convert 50 ml? So I will convert it here itself. So I will convert it like this: 50 ml in 1000 ml per liter in grams into milligrams. This is nothing but just unit conversion.
Okay, sir.
W2 minus W1 into 10 to the power 6 divided by 50 milligram per liter. If you solve it, total solids you will get 722 milligram per liter.
Okay, sir.
If you want to calculate fixed solids, you have to subtract W3 minus
W
W1.
minus
Likewise, you can do
basis.
into 10 to the power 6 divided by 50. It will be same in milligram per liter. If you solve it, if you have calculator, you can solve simultaneously itself.
Okay.
You can tell me what is the answer. Means, have you actually copied the question or not?
No, sir. No, sir.
Okay, it my
53.4625 minus 53.5433. Sir, it's around 384.
correct, correct. It is 384 milligram per liter. And now we will calculate. Fixed solids are also called inorganic solids. Okay. Now we will calculate total suspended solids. It will be W5 minus W4 into same 10 to the power 6 divided by 50 milligram per liter. If you solve it, you will get 242 milligram per liter. And if you solve the TDS, it will be total solids minus total suspended solids. It will be 480 milligram per liter. So likewise you can do. If you do it, it will take more time. So I have solved this concept now. Means I have told this concept. So if you use this concept, you can solve it, and the answer you will get is also here.
Okay, sir.
Yeah. Otherwise, you will lose interest if you solve too much. That's right. So this is the answer. You can match after that.
Okay, sir. Okay.
You will solve some small questions. So like this thing you can try. Express the following concentration of elements and compounds as milligram per liter. These are actually compounds only. I have removed the elements. These are very easy. So can you try it?
No, sir. No, no.
Okay, I will try. I will. So what we have to do, express the following concentration of compounds as milligram per liter of CaCO3. So we have to express it in terms of CaCO3. So how to do?
Okay.
There is a concept called equivalent.
Okay, sir. Equivalent, right?
Yeah, equivalent. So what we have to do, we have to find the equivalents of one compound, and then that much amount of equivalent will be of CaCO3 only.
Okay, sir.
So I will find the first I will calculate this. Can you calculate the molecular weight of MgSO4?
Just a minute.
Take 24 as mg. Tell me this.
120, sir.
Yeah. So it will be 120 grams. So then we have to calculate then equivalent weight. Do you know how to calculate the equivalent weight?
Yes, sir.
How?
120 divided by 2, that is 60.
Yeah. 120 divided by
2.
2. So that is called combining capacity.
Yes, sir.
So for salts, it is the charge. For a redox reaction, it is the number of electrons transferred.
Oxidation state.
Yeah, number of electrons transferred. So we will balance the redox reaction and then we will calculate the number of electrons transferred like that. So here in our case, it is like Mg2 plus and SO4.
Basically for 2
So Mg
minus.
has 2 charge here. And if you see about Al3SO4, Al2SO4 3. For this, can you tell
Sure, sir.
how much will be the combining capacity?
Its mass is around 342.15, sir.
No,
342.
no, just tell me it's actually combining capacity.
114.
No, no. Combining capacity, how much? Al2SO4 3. What is the combining capacity? So its molecular weight will be something divided by Cc, combining capacity. Will it be 2, 3, or 6?
Aluminum plus 3, sir.
Yeah, for this actually compound, how much will be the combining capacity? 2, 3, or 6? For this, actually, it will be
SO4, each SO4 minus 2. 3 into minus 2, that is 3 into minus 2, 6, 6. 3, sir.
no. For that, it will be 6. See, Al3 plus there are 2 Al. So 2 into 3, 6. If you see SO4, 2
Minus
molecules
2.
into 3, 3 into 2,
3.
6. So it has
6.
so it has 6. So the combining
6.
capacity will be 6. Molecular weight divided by 6. So
Six.
it will be the equivalent weight
Okay,
of
sir.
Al2SO4 3. Understood now?
Yes, sir. Yes, sir.
So likewise, we will solve one question. So for this, it will be 120 divided by how much? 2. It will
2.
be 60.
60.
So 60 grams. Now we will calculate number of, that is equivalent weight.
For MgSO4, sir, or ALTSO4 types?
No, for first we will do it for MgSO4. Al2SO4, just I told for the reference that how to calculate. For MgSO4 only. Hi. Hi, yes, I can hear you. Hello. If you have doubt, you can text also.
Hello.
Yes, yes, yes. Then,
Yes, sir.
so shall I start?
Yes, sir.
Okay, okay. So equivalents We have calculated the equivalent weight. Now we will calculate number of equivalents or gram equivalents. It is sometimes called equivalent or sometimes it is called gram equivalents.
Yeah, equivalents.
Gram equivalents is given weight by equivalent weight. Okay. For MgSO4, the given weight was how much? It was
420.
420. So we will take 420 and you will divide it by equivalent weight. How much it was? 60 now.
60.
60, yeah. So it will be, it will, but it
7.
was in what? It was in milligram that we have to take care.
Okay, sir.
See, it was in 420 milligram. We need to take care of that. So it will be
Okay.
7, I think.
Yes, sir. 7 into 10 to the power minus 3.
So it will be equivalents. Or we
Okay,
can
sir.
write it as 7 milliequivalents. Understood?
Okay, sir.
And then we have to convert it in the form of CaCO3. So 7, so we have 7 milliequivalents of MgSO4.
MgSO4.
So same 7 milliequivalents we will have for CaCO3.
Okay, sir.
So now we need to calculate for CaCO3. So what is the molecular weight of CaCO3?
100.
100 grams or milligrams? Grams only.
100 grams.
What is the equivalent weight?
8.8 by 2.
100 divided by 2, it will be
That
50.
is
50
50.
grams. So in one equivalents, there will be 50 grams.
50 grams.
Okay. So in 7 milliequivalents, it will be 7 into 10 to the power minus 3. I'm writing it in the form of equivalents. And then 50. And then I'm converting it in the form of uh, milligram.
Okay,
Okay.
sir.
Yeah. So it was 420 milligram per liter. Okay. So 10 to the power minus 3 will cut and it will be 350 milligram per liter.
350 per liter.
Fine. So now
Yes, sir.
can you solve same for this thing also? 221 milligram per liter of CaHCO3. It's easy only. Take 1 or 2 minutes and try to solve. So what is the molecular weight of CaHCO3 2?
I'm calculating, sir.
Correct, correct. Good.
It's around 161, sir.
162, I think. Can you cross check it again?
Yes, sir. It's 162.
Yeah.
Plus 60.
Okay.
Yes, sir. 162. 81. 2 point.
Have you calculated? Check.
Yes, sir.
Correct.
Yes, sir.
Okay, so likewise we will solve this also. We have to solve it same in the same manner. So express the following molar concentrations of elements and compounds as milligram per liter. So I've removed the elements, otherwise it would be big. So for these compounds, we need to calculate the same thing. So it is easy here because we know one formula, normality is equal to
Wait, wait.
into molarity. Can you tell what is this thing? Normality is just into molarity.
Equivalent weight.
It's actually combining capacity, which we studied
Combined.
previously. So if you know the molarity, you can convert that thing into normality by multiplying it with combining capacity.
Combined.
So for SO3, 2 minus combining capacity will be 2,
2
and normality will be 2 into 1.5 into 10 to the power minus 3,
minus 3.
3 into 10 to the power minus 3. Normality units are in normal. So, and normal is nothing but equivalents per liter. Equivalents per liter.
Per liter.
So, same number of equivalents, we have to convert it in the form of CaCO3.
So this is over 3.
So, we will multiply it with 3 into 10 to the
50.
power minus 3 into 50
50
into 10
into 10
into
to the power 3.
1000 milligram per liter. Can you solve
That
it
is,
and tell what is the answer? It will be 150 milligram per liter.
okay, sir.
Correct? For the other
Okay, sir.
question, it is, wait, I will add one more because what was the question? 3 into 10 to the power minus 3 mole per liter of NaOH.
NaOH.
3.5 into 10 to the power minus
It
3
is 3.
mole per
Mole per
liter
liter NaOH
NaOH. So normality
is equal to
is equal to
combining
combining
capacity
capacity into molarity.
molarity.
So here the combining
1,
capacity of NaOH is Na
1,
plus and OH minus, so it's one only. So
1
here moles will be equal to equivalents. So how much 3.5 into 10 to the power
into 10
minus
to the power minus 3 into 50
equivalents per liter, and we will multiply it with 50 and 10 to the power minus plus 3.
3
It will be in milligram per liter. We
milligram.
cancel it,
We can cancel
and if we will solve,
3.5 into 175 milligrams.
correct,
Yes,
correct.
sir.
And we have to write it as 175 milligram per liter as CaCO3.
CaCO3.
If we don't define as, but then our answer may or may not be correct. May not be,
Okay.
will not be correct. So 150 milligram per liter as CaCO3. Right. Then these are some small questions that you must read. Can TDS be calculated from specific conductivity of water?
Yes, sir.
Yes, it's true. And what about the second question? Are tests reliable for all waters?
I didn't understand the question, sir.
First question, did you understand?
Yes, sir. Yes, sir. I am not understand. I didn't understand the second question.
Okay, okay. That's why it is there. Okay, I will tell. See, TDS, how we will calculate? We will calculate TDS in
It was
milligram per
the
liter by multiplying it with the factor which ranges from 0.55 to zero point 0.7 into specific conductivity.
Okay, sir.
Correct?
Sir, I think it's 0.6 something, sir. Yesterday I have answered it.
Yeah, it's 0.67, but for different
Six, sir.
waters and different ions, it will vary.
Okay, sir.
So specific conductivity is micromole per centimeter, that is, or millimole. That I don't I'm not sure. So the thing is that specific conductivity, there is a limitation with the specific conductivity, not with specific conductivity with TDS, because what will specific, what will this term tell? It will tell us the ionic species concentration. So what we have studied, TDS is what TDS will contain inorganic dissolved
Inorganic and
solids
organic.
and organic dissolved solids. So what specific conductivity will measure? It will measure only inorganic
Inorganic
dissolves.
solids.
Understood somewhat?
Yes, sir. Yes, sir.
So it will tell only inorganic dissolved solids. So organic dissolved solids will not be counted here.
Okay, sir.
So that's why in those waters where inorganic dissolved solids are more and TDS is less, there we can use it. Okay. But in our wastewater, organic dissolved solids are more. So we can't measure TDS through this equation. So for that, we need
Okay.
to do the test which we performed, which we solved just a few minutes back. We solved one big question. Huh?
Yes, sir.
From that method, we need to calculate the TDS, and those tests are reliable. This
Okay, sir.
test will not be reliable for the
Okay, sir.
wastewaters which have high dissolved organic content.
Okay, sir.
Correct.
By evaporating the water at different temperatures, 105 and 550 degrees, sir.
Yeah, like that. Correct.
Okay, okay,
Are
sir.
tests reliable for all waters? No. Specifically, when dissolved organics are present, then it is not reliable. What is true color? Do you know?
No, sir. We will measure the color by comparison method. Hasn't seen it, sir.
Correct. So, color in water or wastewater, there are two types of color. One is apparent color, and another one is true color. So, true color is only due to dissolved solids. So, in water, it can have dissolved solids and suspended solids. Okay, so the true color is only due to the dissolved solids. The
Dissolved solids.
apparent color is due to dissolved solids and suspended solids both.
Suspended solids.
So if we
Okay,
remove
sir.
the suspended solids, we get
We will get the
true
true
color.
color.
So that is called true color. That's it. Turbidity is due to, then study it. Read this sentence.
Suspended solids.
Suspended solids, but not all the suspended solids will cause the turbidity. These are specific solids. These are called colloidal solids.
Colloidal particles.
Yeah, colloidal particles will cause turbidity.
Turbidity.
These
Scattering of
solids, yeah, these solids like floating solids will be like leaves, some other materials in wastewater. These will not cause turbidity.
yes, sir.
Simply,
Yes, sir.
okay.
Actually, I didn't see the options, sir.
Yeah, no issue. Read this question. Treatment of water wastewater depends on,
Decide the quality of available water. Decide the quality of both, sir. Both one and two.
correct. We need to know what is the existing quality. We need to know what is the desired quality, and based on that, we will design our efficient. We will design our units. Correct. Do you know how to measure alkalinity and what is alkalinity
Yes.
actually? Hmm?
The neutralizing capacity of water, acid neutralizing capacity.
Correct. And do you know this? How to measure?
Yes, sir.
Titrimetric method we use.
Hydrometric
Do you
method.
know which titrant do we use?
sulfuric acid,
Yeah. How much we use generally? 0.02 normal.
0.02 molar. Normal,
Uh,
okay.
H2SO4. Indicator?
For hydroxide alkalinity, it is phenolphthalein.
Phenolphthalein, correct. And for bicarbonate
I have
alkalinity?
small doubt here, sir.
Yeah, tell.
Actually, we are measuring alkalinity by means of phenolphthalein and indicator and methyl orange indicator for total alkalinity.
Yeah.
Uh, in class today morning, I watched second week video. There,
Mhm.
sir said that it is a mixed indicator, sir. Is it universal indicator?
No, actually, so I think sir may be following some different textbook. But let me tell you, I have just 2 days back I did alkalinity test. So what we use in general, we add phenolphthalein alkalinity. I'm denoting it as P, and
P.
it will turn if the pH is more than 8. I will write it in another. Okay, I will start. Then it will clear your doubt. Mixed indicators generally we don't use in our lab. See, if pH is more than 8.3, even though if it is not more than 8.3, we will add phenolphthalein.
Phenolphthalein.
Yeah. So phenolphthalein, what will it do?
It will commence with hydroxide and gives pink color.
Yeah. If water is colorless and more than 8.3, then it will give the pink color.
Pink color.
And after the pink color is will
After the titration, it will changes to colorless.
yeah. So we will titrate it with 0.02 normal H2SO4. Then pink color will again turn into colorless, and then we will add methyl orange. Then it will convert. Then the color will be yellow, pale yellow in color. Correct? And then we'll titrate.
Just a minute, sir.
Yeah.
Hello,
Yeah.
sir. Okay. Okay, sir. I understand it, sir.
So from pale yellow it will be
It will convert to orange or reddish tinge
yeah
color, sir. Orange,
orange or little bit light pink.
pink.
So this is the procedure. And what we will do, okay, I will teach in the form of this graph. So first we add phenolphthalein, then we will add, can't write actually. Okay, I will make it here. This pH will be 8.3. This point will be 4.5.
4.3.
This will be around more than 8.3. Let's say it is around 10
12
or
over 10.
10 or 11. Okay. So in y-axis it is pH. So
Okay.
we will measure the pH and we will measure the amount of
Volume.
titrant
Volume.
used. So this is titrant.
Okay, sir.
So it will have some alkalinity, this water. This will be ml of titrant used.
Right. Okay.
So we will put phenolphthalein here, we will put methyl orange when phenolphthalein color will disappear.
Disappears.
Yeah. So yeah. So there is one more thing. So in this region, only OH minus and CO3 2 minus alkalinity,
So,
these two species are present. And while in this region,
bicarbonates.
yeah, bicarbonates are present as CO3 minus. So in when this is P, so the amount of H2SO4 consumed in this first region will call as we call it as phenolphthalein alkalinity, and from this
Phenolphthalein
region
alkalinity.
it is called as methyl orange alkalinity.
Methyl orange
Total,
alkalinity.
the M is taken as from initial
Total alkalinity.
to final. Yeah, this is also called total alkalinity. One more thing, let me tell you. So here pH will be 8.3, it will be 4. Oh no, it's wrong. Let's say pH is around 11, then 8.3, then it will be 4.5. So this will we call it as P.
Pin of 3.
Then we call this as M. And now we'll talk about species. So here we will have OH minus,
Hydroxide and
CO3 2 minus,
bicarbonates.
and here it will be
Bicarbonates.
bicarbonates. Yeah. So what happens? So in this region, the OH minus will be converted into H2O,
H2O.
and CO3 2 minus will take one H and it will become HCO3 minus.
HCO3 minus.
So in this area, what will happen? OH minus will be utilized. OH minus alkalinity will be neutralized, and
Neutralized.
but half of the CO3 2 minus
CO3.
will be
Okay, sir.
utilized. And here in this region, half of the CO3 which is produced from this will be here, and HCO3 minus will be there. So this will be in the form of HCO3 only.
Okay, sir.
Understood? Na? So like this will be depicted. And one more thing. So here, for the ease of calculation, we use this concept. This is important. So if 0.02 normal H2SO4 is used in titration, then 1 ml of that titrant, this 0.02 normal, then 1 ml of acid will neutralize 1 milligram of alkalinity as CaCO3. So we will use this concept in questions. So are you aware of these things? P is equals to M, P is equals to M by 2, P is equals to 0.
No, sir.
Okay, then I will tell you.
Actually, it is similar to the concept which you have explained, sir.
Yeah, it will be
P
easy.
is OH equal to OH. That means all the hydroxide ions will be neutralized. M by 2, since it is half of the CO3 is converted into HCO3. That's why I think it is used M by 2.
Wait, I will tell. Yeah, from starting itself. Okay, we'll start from this P is equals to 0. P is equals to 0 means phenolphthalein alkalinity is 0.
Phenolphthalein is 0.
It means when we add phenolphthalein, the color will not change. It will be
Changes
colorless
to pink
only.
color.
No, when we add,
It does not changes to pink color.
yeah, does not change to pink color. So that means only SCO3 is present. Only this part means only this part will be present in this case. Understood, na?
Yes, sir.
Yeah. And when P is less than M by 2 means this portion will shift left side.
Okay.
P is less than M by 2. Then dominant species will be CO3 minus and SCO3 minus.
So, yes.
Then OH will be less and CO3 and SCO3 will be dominant.
Okay,
Understood,
sir.
na?
Okay.
Yeah. And when P is greater than M by 2 means this line will shift right hand side.
Towards the right side.
Yeah. And predominant in that case, the predominant species means this part will be smaller. This part will
Okay,
be
sir.
smaller and this part will be bigger. So if this part is big, that means predominant species are OH minus and CO3 2 minus
And
because
CO3 too.
yeah, means this part will contain OH and CO3 2 minus. That's why. Now we will come to P is equals to M by 2. So that means left and right both are equal. P is M by 2 means it means OH
Okay.
minus is absent and SCO3 minus is also absent. So the total alkalinity will be due to CO3 2 minus.
CO3 2 minus carbon dioxide.
And when P is equals to M, P is equals to M means it is stopping here itself. Means if we put the methyl orange then it will be orange, and the pH will be directly 4.5. Only this portion will be covered here. Understood?
Yes, sir.
Yeah, I think the pH is not 4.5, but the thing is that only methyl orange will be only uh, this part will be covered here, and this portion will not be there. So when P is equals to M, only OH minus alkalinity will be present, and rest these two species will not be there. CO3 2 minus and SCO3 minus will not be present in the water. The pH will be around 8.3 only in this case. So this is about alkalinity, and we will solve few questions. Yeah, this is a question of alkalinity. So a 100 ml sample of water is titrated with 0.02 normal H2SO4. So this is a sample. We are titrating it with 0.02 normal H2SO4. The initial pH of water is
9.
9.5. pH is in y-axis. And 6.2 ml of acid is required to reach the pH 8.3. So how much ml is required? I will write it in y-axis. 6.2 ml is required for this phase, and additional 9.8 is required. 9.8 ml is required to reach the 4.5 endpoint. 4.5 is required. Determine the species of alkalinity present and the concentration of each species. So can you solve? Can you try to solve? Okay, I will do.
6.2 into 0.02 into 50 into 1000 by 100. 500 into 6. 160, sir.
Yeah,
Total.
it is total alkalinity now. 160 16 divided by 100. That will be 160 milligram per liter
160 milligrams per liter.
as COCO3 that we have to write. So, but this is OH minus plus CO3 2 minus
CO3 2 minus
plus
plus CO3
CO3
minus.
minus. That sum of these three will be 160 milligram per liter. Then how to calculate these three individual alkalinity species? So what is the initial pH?
6.2 Initial 9.5.
9.5. So initial pH is 9.5. What will be pH? From this pH, we can calculate the OH minus alkalinity. 10 minus 9.5 will be how much? 4.5, I guess.
Yes, sir.
And then OH minus will be 10 to the power minus 4.5 into 50 milligram per liter. How much will it come? Can you calculate and tell? That will be 50 into 1000 because it will be in gram. Can you tell after solving this? What will be the answer? It will come as 1.58 milligram per liter as CaCO3. So for phenolphthalein alkalinity, how much volume was consumed? 6.2 ml.
6.2.
2 ml. So this will calculate. So for phenolphthalein alkalinity, how much will it contain? It will contain OH minus plus half of CO3 2 minus
CO3 minus.
will be present in phenolphthalein. So what we will do, we'll calculate this much amount of phenolphthalein alkalinity. How much it will be? 6.2 milligram by 100 into 1000. So it will come as 62 milligram per liter. So it will be 1. So if I calculate CO3 2 minus alkalinity, will come as 62 minus 1.58 into 2. That means it will be 120.84 milligram per liter. And then we know OH minus, we know CO3 2 minus, then we can calculate SCO3 minus alkalinity. So the total is how much? 160 milligram per liter.
160.
Can you tell SCO3 minus alkalinity?
160 minus hydroxide 62.
It will come as 37.58.
Okay. Yes, sir.
So this question is complete here. This is SCO3, this is CO3. Bracket will not come in here. Bracket is not required. So this is SCO3 here, this is CO3, and OH minus we calculated here. Now we will solve one more question on alkalinity. The initial pH of water is 7.5. Initial pH is 7.5. 200 ml sample we have taken. It started with 0.01 normal. See, this is the change here.
Yes, sir.
Earlier we used 0.02 normal, but now we are using 0.01 normal. And the pH 4.5 endpoint,
15 ml consumed.
15 ml is utilized. Can you calculate the total alkalinity? And one catch is there. Two things to note. One thing is that pH is less than
8.
is less than
8.3.
8.3. So that means OH minus and CO3 minus will not be
The
present.
oxygen. Yes,
Okay.
sir.
Second thing is what? 0.01 normal of H2SO4 they have taken. So we can't
Yes, sir.
use one line we studied na, like 1 ml will produce 1 ml will utilize will be equivalent to 1 milligram of alkalinity as CaCO3. So this will not be applicable here. Okay, we will do it. First, we will calculate the total alkalinity.
Alkalinity.
Can you calculate Intel? I will simultaneously calculate.
15 into 0.01 into 50 into 1000. So total volume is 100 ml or 200 ml?
200 ml.
200. 37.
Yeah, correct. 37.5, I think. So 0.01 normal is there na. So we will multiply it with 0.01 and by 15 ml to calculate the equivalents. That 0.01 is equivalent per liter, and we'll multiply 15 ml 1 liter by 1000 ml. We will calculate, so it will have 0.15 milliequivalents. So same equivalents of alkalinity will be there. 0. 0.1 into 50. How much? It will come as 37.5 milligram per liter
Milligrams per liter.
CaCO2. It's easy, I think.
Yes.
Yeah, correct. And one more thing to tell here. Here we calculated the total alkalinity is total alkalinity. I'm writing it as Ta. It is in the form of HC3O, HCO3 minus. Okay. It is in the form of HCO3 minus.
Yes, so
Total
increment.
alkalinity in the form of HCO3. But we have pH also. Na? Can we calculate OH minus? And you will get to know that how much is was the pH? 7.5.
5.
pH was 7.5. So pH will be how much? 6.5, I think.
6.5.
Yeah. And then OH minus ion concentration will be 10 to the power minus 6.5.
Minus
And if
6.5.
I calculate in terms of CaCO3, how much it will be? 15 to 10 to the
If
power
into
3.
10 to the power minus.
So how much will it come? It will come as 0.0158. I will write it again. 0.0158 milligram per liter. So it's very, very less. So that's why we are neglecting. Understood, na?
Yes, sir.
Yeah. So these were two questions based on alkalinity. Now we will again study what this was alkalinity. Yeah, there are some MCQs. Have you studied the hardness?
Yes, sir.
Yeah. So hardness is mainly due to we know.
Calcium and magnesium salts.
Yeah. Why not sodium? Actually, it is imparted by multivalent cations. That's why sodium does not impart any hardness. And
Okay, sir.
hardness, yeah, and hardness is of two types. One is carbonate hardness and one is non-carbonate hardness.
Non-carbon.
Carbonate hardness is also called temporary hardness.
Temporary hardness.
And it is called as permanent hardness. So the anions which are associated with calcium and magnesium, what are those? Chloride,
Chloride
chlorine,
sulfates.
nitrates. Nitrates,
Nitrates.
correct? Or some other,
Nitrates are not there, sir. Chlorides and sulfates.
but sometimes nitrates are also present. So CO3, 2 minus, SCO3 minus. These are the anions which will cause temporary hardness. And it is
Temporary
called as,
hardness.
yeah. Now you can solve the MCQ. And one more thing, temporary hardness can be removed
Eliminated.
by heating. Are you
Boiling.
aware na? Okay. And the hardness, why is it important to study the hardness? Because in drinking water, it is not much concern.
In industrial water, it may causes a sludges or scales formation.
Correct, correct. This is the main thing. And one more thing, if hardness will be present na, in water distribution, we use pipes.
Yes, sir.
Pipes. So it will affect the pipes. It will cause incrustation. Means that suppose this is a pipe, so it will form a layer. Okay,
Yes.
and it will reduce the discharge carrying capacity, reduce the discharge. So then we have to again replace the pipes again and again. So in order to reduce uh, the cost of changing the pipes, we better don't send the water which has high hardness. Understood, na?
Yes, sir.
So yeah, now you can solve the questions. Which of the
Water.
following? Yeah, tell.
Temporary hardness. Calcium sulfate, magnesium sulfate, magnesium chloride. Temporary hardness means it is bicarbonates, sir. Carbonates. Option D.
Correct. This question, temporary hardness in water is caused by temporary
Magnesium
hardness.
carbonate.
Now second questions.
Temporary hardness is caused by bicarbonates of calcium, magnesium. Yes, sir. Option A. Option A and B also, sir. Option A and C for second one.
Temporary hardness,
Bicarb.
they are asking temporary hardness.
Yes, sir.
This is nitrate.
Carbonates, sir. Carbonates. Carbonates. Okay.
Which answer? Which
Okay.
option?
I thought it was bicarbonate. Okay. It is binitrates. Okay.
Yeah, that's
Option
correct.
C is correct.
COG. Yeah. So nitrates will cause permanent hardness.
Permanent hardness.
Correct, correct. Uh, Read this. Which of the following is a waterborne disease?
Typhoid, cholera, diarrhea, all of the above.
Correct. Which of the following salt is the main cause of permanent hardness of water?
Magnesium sulfate.
Correct. First one is the answer. How to measure hardness?
By titrating with EDTA
Correct.
using EBT indicator,
Correct. And if we use,
ammonia buffer.
yeah, yeah, ammonia buffer to increase the pH. Note that if 0.01 molar EDTA is used, then 1 ml of titrant measures 1 milligram of hardness. Like we studied in alkalinity, na? This is the same equivalence. Through equivalence concept, we have formulated uh, this but note. So shall I write like how to means how these equations are? I will write. It will not take much time. So what happens now? Calcium, magnesium ions present in water will react with EBT and they will form calcium
One magnesium metal
EBT.
EBT
Yeah,
complex.
it is a complex. It
Wine
is a
red color.
Yeah, wine
wine
red.
red color.
Correct. Wine red in color. And then this is
We
the
will
EBT is the indicator. So after putting few pinch of indicator, we will titrate it with EB with EDTA.
EDTA.
Yeah. EDTA when we titrate it with calcium magnesium complex, then a displacement reaction occurs. So this calcium and magnesium, it will attach
Form
with
stable
EDTA.
complexes with EDTA.
Yeah, they will form a more stable complex that will be calcium, magnesium, EDTA, and that EBT will give its color.
Will be
So
available
this,
in the water.
yeah,
Blue color.
this will be colorless, and this will give its blue color.
Blue color.
So this blue color will tell us that this is the end point of the
Blue
titration,
color.
and we will measure the
Volume of EDTA.
volume of EDTA consumed. Correct? Yeah, we will measure and VML. If VML is consumed, then V milligram of hardness is present in that much amount of water sample. Okay. So now some more MCQs are here.
Fluorosis option 3.
Correct. Fluoride. Fluoride,
What
do you
type
know?
is
Yeah, tell. Please.
methanoglobia? Oh,
Methamoglobinemia.
nitrates.
Nitrate. Do you know the another name for methemoglobinemia?
Blue baby syndrome.
Correct. How it happens?
During pregnancy time, ladies may affected with high nitrate content water. The born baby will be in dark blue in color. This may lead to miscarriage.
I studied in PV. They are telling like the babies have less acidity in their stomach.
Okay, sir.
The stomach and their stomach has less acidity. So what happens
The
because
digestive
of
system will be.
yeah they tell. So the nitrate which is present, so if they will consume nitrate, the nitrate will be converted into nitrite, and nitrite is very much toxic. So
Toxic.
no, sorry, what happens? So nitrite, what will it do? It will combine with hemoglobin.
Okay, sir.
So that nitrite will combine with this hemoglobin, and otherwise hemoglobin will carry the oxygen. But
Yes, sir.
now NO2 has more affinity towards hemoglobin, so HbNO2 will form and it will not take oxygen. So because of the lack of oxygen, the baby becomes blue.
Okay,
So
okay.
this is what described in PV role of environmental engineering. Yeah, I read the third question. During the formation of
Permanent teeth.
permanent teeth, dash combines chemically with tooth enamel, resulting in the harder, stronger teeth that are more resistant to decay.
Sulfates.
No, it's not sulfate. It's fluoride only.
Fluoride.
During the formation of permanent teeth,
Okay, sir. Even enamel also contains fluoride. Okay.
yeah, actually fluoride when it is less than 1 milligram per liter, it is helpful.
Yes, sir. Yes, sir. That's why we are using Sensodyne or something which contains fluoride.
Yeah. But if you consume it more, uh, if concentration is more than 1.5 milligram per liter, then it will cause fluorosis, decoloration of teeth.
Yes, sir.
Uh, and if it is more than 5 milligram per liter, it causes bone fluorosis like that. Our bones become brittle and they will break easily.
Yes, sir.
Read this question: different forms of organic nitrogen present in water. Are you aware
Different
of it?
forms of ammonical nitrogen,
Yeah, correct.
nitrate, and nitrite.
Nitrate,
I
uh,
didn't know about organic nitrogen.
You initially you told na urea. Urea is organic nitrogen.
Okay, sir. Okay, okay.
Correct. This is organic nitrogen. So what these different organic actually when we discharge, let's take an example. It will be easy to understand all this. See, suppose this is a river. So there is a sewage treatment plant. Let's say one day they will not. No, let's not take the example of sewage treatment plant. Let's take a community which is discharging its sewage here. So the thing is that if sewage is in the initial phase, it will contain free ammonia. Free ammonia describes recent pollution. So near this, near the point of disposal, you will get ammonia here or ammonium. Okay, but when this with the stream, the sewage will also move,
Okay,
and
sir.
with some time, after some time, if you measure at some other section in the downstream, this is downstream, so you will find nitrite because of oxidation. Free ammonia will oxidize to nitrite,
Nitrite.
nitrite oxidation, and nitrite will tell partially decomposed, partially
Decomposed.
decomposed organic matter.
Organic matter.
Okay, the spelling is not correct. Let's correct it. And what about nitrate? Partially decomposed organic matter. And when further it will oxidize
Nitrate.
to nitrate, and it will tell fully oxidized
Oxidation.
to the organic matter. Nitrate is very toxic. Its limit is zero, and nitrate is not toxic, so its limits are 45 milligram per liter as nitrate only.
Okay, sir.
If you take in terms of nitrate nitrogen, its limit is around 10 or 11 in the form of NO3.
NH3.
NO3N, that I will talk about these two things later.
Okay,
So
sir.
for this nitrogen, 10 milligram per liter is the limit. And that organic nitrogen, one other form was organic nitrogen. It will tell us about the complex organic matter present in the water. Complex organic matter. Yeah, it is here. I have shown it. Organic nitrogen will tell us what?
Urea.
It will tell us the presence of complex organic matter. Ammonia nitrogen will tell us recent pollution. Nitrate
Some
nitrogen
pollution.
will tell
Nitrite partially
partially
decomposed.
decomposed. Nitrate nitrogen fully decomposed
Fully
organic matter.
decomposed.
Understood. So this, so what happens now? If we want to know that how old is the sewage, we will take how old is the pollution. So we will take the sample randomly, and then we will tell, okay, so this is recently polluted, or this is around 2 3 days old, or what. So based on the kinetics of degradation, we will tell, okay, this is recent pollution, or this is partially decomposed, or it is fully decomposed. So that's why it is used. So are you aware of this thing? Nitrate, nitrogen, nitrite, nitrogen,
No, sir.
nitrate, nitrate. Okay,
I
alright.
didn't know.
So ammonia, what is the molecular weight of ammonia? 14 plus 3,
14 plus 3.
17.
17.
So we actually, yeah, for ammonia it is 17. For nitrate, how much it will be? 14 plus 16 into 2.
32 plus 1. 46.
How much it is? 40.
46. 6.
Tell for nitrate also.
48 plus 40, 62.
62. These are all in grams. So we are, instead of nitrogen, we are taking hydrogen also here. Instead of nitrogen, we are taking 2 moles of oxygen also here. Here we are taking 3 moles of oxygen also. Okay, so what we do in this form, we just express all those things in the form of nitrogen only. So suppose if 17 gram ammonia is present, we will denote it as 14 gram only. 14.
Okay,
If
sir.
if 46 gram is present, we will take it as 14 gram itself.
14 grams of, okay.
Yeah. And if 60
62 grams of nitrate is equals to 14 grams of nitrogen.
14 grams of nitrogen. That's it. We won't consider oxygen and hydrogen in that case. And these questions we have solved. Yeah. So BOD, do you know what is BOD and how to calculate?
I am not aware of calculating BOD, sir.
Okay. BOD, do you know little bit?
It's biological oxygen demand, the amount of oxygen required to decompose organic matter by microorganisms.
Correct. You told it correct, but its name is biochemical.
Biochemical oxygen.
Yeah. Biochemical oxygen demand. Yeah, correct. So for biochemical oxygen demand, we do BOD test. Are you aware of little bit?
I am aware of COD, but I don't know about BOD, sir. I know about COD, chemical oxygen demand.
Correct. I will tell what is BOD. So what we'll do now in BOD test, we will take 300 ml bottles.
Okay, sir.
So BOD means oxygen requirement. So how much, suppose the water sample is there, so how much oxygen required for the decomposition of organic matter by the microorganism is called biochemical oxygen demand. Okay. So the thing is that we take if we keep the water sample, the water will be devoid of oxygen. So what we will do, we will take some amount of sample, we will dilute it with aerated water. This is sample. We take the water sample, we dilute it with aerated and sometimes seeded water. Understood? We
Yes,
will
sir.
take sample water. Let's take we have taken sewage and we will mix it with aerated water so that we will get to know that how much oxygen is consumed by the microorganisms present in the sewage. Okay, we will check the initial DO. Do you know about the DO dissolved oxygen?
Yes, sir.
Initial DO, we will check it. That is called DO initial. Then after 5 days, also we will check the DO that is called DO final. And then we will subtract DO final minus DO
Minus
initial.
UA initial.
And then actually that demand, the difference is due to the whole water. But we need to calculate it for the sample only. So
Sample
how many,
water.
yeah, for how many times we have diluted it? So this sample is 300, this bottle size is 300 ml.
Okay, sir.
Yeah, so 300 ml divided by this, let's say it is x ml. X.
Okay, sir.
This will be the BOD.
Okay, sir.
So generally the BOD is done for 5 days at 20 degrees Celsius. So we will solve it. It is a very easy question. So BOD in a BOD determination, 6 ml of wastewater is mixed with 294 ml of diluted water containing 9.1 milligram of dissolved oxygen. So initially what they are doing,
Taking 6 ml of wastewater.
yeah, 6 ml of wastewater they have taken and then 294 ml.
294 ml of diluted water.
Yeah, correct. So it has, so that this mix has DO initial of
9.1.
9.1 milligram per liter. After 5-day incubation at 20 degrees Celsius, dissolved oxygen
It's
content of the
2.8.
mixture is, yeah. So what will happen after
Okay.
5 days? The microorganism present in the sewage or this sample will consume oxygen from this water, and the
Yes, sir.
oxygen content will reduce. So the oxygen of this mix after 5 days will be how much? It is showing as it is written as 2.8 milligram per liter. Understood?
Yes, sir.
So BOD 5 days will be 9.1 minus 2.8 into
Into
uh,
300
300 divided
by 6.
by 6. Correct. How much will be the answer? Can you calculate?
If 33, 335.
335. Let me check. Yeah, 315 or how much? 315, no?
Yes, sir. Yes.
If I'm not wrong, it's 315.
335.
335. 9.1 minus 2.8 into 300 divided by 6. 335 or 315?
Just a minute,
You
sir.
check it. You please cross check it again. It's 2.8. It's 300.
It's 315.
Yeah, correct, correct. Shall we start with the new question?
Yes, sir.
Okay. Which of these metals are toxic? And
Mercury, Hg,
yeah,
cadmium,
mercury, cadmium,
arsenic, As,
arsenic, silver. Silver is also toxic. These are toxic metals: silver, arsenic, cadmium, mercury.
cadmium.
So their low concentration means actually heavy metals are toxic. These are all heavy metals. And aluminum, calcium, iron, and manganese, these are not toxic actually. So this question, pH, are you are you aware of
In the
pH?
back.
Hmm? Hello? A wastewater sample contains 10 to the power minus 5.6 millimole per liter of OH minus ions at 25 degrees Celsius. The pH of sample is, so okay, I'm starting it. So what is the question saying? The OH minus ion concentration. Like
8.4, sir.
8.4, but the answer is not 8.4, it's 5.4. How did you calculate?
It's in the question. It is he has given OH minus ions concentration, sir.
Yeah, correct.
Uh, Total pH 14 minus 5.6.
No, actually it's not mole, it's actually millimole. It's a gate question. So the it will be minus 5.6 into 10 to the power minus 3 mole per liter.
Okay.
So it will be 8.6 mole per liter. And then if you calculate H plus and concentration, then it will be, wait, I'll write like this. We know about this thing, OH into H plus, it will be 10 to the power minus 14.
Yes.
Then you need to calculate for like
H
this,
plus.
plus 8.6. And it will be 10 to the power minus 5.4 H plus.
Okay, sir.
If you solve it, you will get pH 5.4. Correct? So the correct answer is 5.4.
Okay, sir.
Done. Can we start the next question?
Yes, sir.
This is the last question I have for today. If you have further few more questions, we can discuss that. So this is based on alkalinity and hardness. The alkalinity and hardness of water sample in milligram per liter are 250 milligram per liter and 350 milligram per liter as CaCO3. So, so the MCQ says that the water has this much calcium hardness or non-zero non-carbonate hardness. These are all the options. So basically, you need to calculate carbonate hardness and non-carbonate hardness. That's it. Can you calculate? Can you calculate it? Okay, shall I start this question? So alkalinity given is 250 milligram per liter and hardness, writing it as total hardness, is 350 milligram per liter. So the question is asking what is the carbonate hardness and non-carbonate hardness. So we know carbonate hardness is minimum of alkalinity and total hardness. So the carbonate hardness is minimum of what? 250, 350. So it will be 250 milligram per liter. And total hardness is how much? 350 milligram per liter. So non-carbonate, we know total hardness is carbonate hardness plus non-carbonate hardness. So non-carbonate hardness will be total hardness minus this carbonate hardness. Total hardness minus carbonate hardness means 350 minus 250 milligram per liter. So it will be 100 milligram per liter. So which answer will be correct? Carbonate hardness 250 milligram per liter and non-carbonate hardness 100 milligram per liter. So D will be correct. So this was about the today's session.